I shall get stuck into it then. So this morning's chapter is about maintenance and troubleshooting. I'll warn you that these slides are very wordy, but a lot of this will, your troubleshooting and that you'll develop when you start doing the labs when we get back in the classroom. So don't worry about it too much, but we'll go through the basic steps and some pointers towards how to do things. So to start off with, we've got preventative maintenance, which basically refers to our main problem, which is dust. Computer equipment always consumes dust. Just looking at my desktop over on my right hand side, it is well and truly due for a good blowout. And part of the maintenance is also looking at the software side, so our updating our patches and antiviruses and scanning is also part of our maintenance routine for our hardware. So it's not the worst case of dust in the intake I've seen, but yes, they can quickly develop a good layer of dust over the intakes because of the static that the fans generate. So it just clumps together quite nicely. So a nice brush and a vacuum can be used, but not like a home vacuum. We're talking about an electronics vacuum. Most environments will use a compressed air can to blow off the dust and a brush to get the more stubborn elements off. Now, word of warning, when you're doing a compressed air blow on fans, just make sure you lock the fan in place before you spray it with the compressed air, because making the fan spin can actually cause it some damage. Just to give you a heads up. So internal components to check for dust buildup is definitely the CPU heat sinks. Basically the dust clogs up the fins and stops air flowing through the heatsink, so it generates more heat, which means it will be more prone to failure in the long run. Other areas to check will be the RAM, basically everything in there, so your RAM, your storage, your adapter cards. So give it a good check, because once the outside fan is coated, you pretty much start building up on the inside. Keyboards and mice, we're all generally guilty of eating at our desk. So not only do we get our lovely elements coming in, we also get food and that dropped in. Yes, Stuart, that's quite right. That's why use a pencil or something and lock the blades and then blow it. You know, they are only quite flimsy plastic, and most of them are very hard and brittle. So when you use compressed air and blowing solids through, like you are when you've got build up on fans, they tend to be unbalanced, and which means they'll hit this casing because of the buildup of material in the fan, which will cause the fins to actually shatter off because of the speed that they're rotating at. So, yes, I've disintegrated a couple over the years. So, just, yeah, can be dangerous to your eyes if splinters come towards you. Alright, so the problem with the heat, as I said, is you have the potential to cause damage to electronics. Now, modern day CPUs will shut down when they get too hot. There's safety protections inside the CPUs for that, especially when overclocking and that. So they do slow down and then eventually shut down when the heat gets too much for them. But your other devices in your case do not have that protection. So they'll just keep building up heat and then eventually fail. And the other thing we've got to be conscious of in a home environment is changes in humidity. So, moisture and electricity is never a good combination. And the problem with the dust buildup is on the circuits, you tend to short circuit because dust is a conductor. Electricity will actually arc out between components across using the dust. So, alright, so on the software side, we need to start looking at updating all of our applications and operating system. So this doesn't have to be done daily, but you need to develop a schedule to keep these things up to date as far as patches and so forth in a enterprise environment. The one thing you've got to be really aware of when you're dealing with enterprise, so you need to comply with any policies the company has as well. So just be aware of that. So at home, definitely get in the habit of having a read on what the patches are for, just to familiarise yourself with what the issues they've discovered and do a bit of research, because when you get in the habit of doing that now, you'll have those habits when you move into the enterprise environment. So keep your antivirus definitions up to date, do a regular scan. Alright, don't just rely on your current running to catch everything, because if it's a 0-day virus, it will come straight through your antivirus, because nobody would have detected it, so your antivirus will not detect it as well. So it'll come into your system, and the only way for you to get rid of it after it's in is to do a full scan. It's always good practice to remove any applications that are no longer current, no longer being used. It just prevents any security issues with those applications being exploited and frees up resources for future use. Now, with scanning hard drives for errors and defragmenting them, that does improve the overall performance of the hard drives, but do not ever defragment a solid state drive. You're just wearing them out faster, because there's a finite number of times they can be written to, and defragmenting is just using that number up faster. Okay, troubleshooting is a skill that you need to develop by doing. This will be an introduction into a logical step-by-step process that you need to develop yourself, and you can develop the habits and processes now, and by actually doing through the labs and trial and error, you will start to recognize common issues, and you will automatically do some of these things in your head without thinking about them as you get more experience. So the first step is to identify the problem. You need to know what you're trying to fix. Second one is to come up with a theory as to what caused that issue to occur. Then the next step is to determine whether or not your theory was the cause of the problem. So try to work out if confirming the problem and the causes, you can come up with a plan to remove the issue and implement the solution. Step 5 is verifying all of that occurred. So did your solution resolve the issue? If it did, move on to step 6, which is document your findings, the actions you did, and the outcomes. If it didn't, remove the fix that you applied and go back to step 3, determining a new theory to resolve the issue. Now, why would I say remove what you did? Very simple. If you keep making changes, you don't know what's causing the issue, the original problem or the changes you've made. So you could be actually increasing the issues by leaving those changes in place. So some of the things documentation wise and that you need to look at is doing the paperwork. I mean, especially if you're on call and visiting clients, you need to have their customer information here. So who they are, who your contact is, where they're located, and how to contact them with a phone number and so forth. The equipment needs to be identified, what the environment that it is in, as in what operating system they're using, what sort of network they're using, what types of connections are connected to the devices. And then you go into, as we've discussed in other areas, analyzing with the open-ended questions over closed questions. The idea is to actually get them to explain what they were doing when the problem occurred. And then follow it up to ask things like, was there any recent changes to the network or things like that? Then following that, you can check on any error messages that came up. Again, when a PC fails to boot, it'll have potential beeping on the post, so it will tell you whether or not there's a main CMOS error in LED. So what are the lights saying? Are the lights turning on? Network cards will have 2 lights for circuit and actual data transmission. And so probable causes, don't overestimate the one that people fail to turn the device on. There's a lot of people that just have no idea how electronics work, and if they normally leave a machine on and somebody's turned it off, they may not even recognize that the device is turned off. Yes, sadly, I've come across this. So check the machine's on, power's on. if they've got a power board with surge protection, make sure it hasn't been tripped. Yeah, reset the power, exactly. So check to see whether all your cables are connected and on solidly. And one rock, the bootable disk, I mean, especially in the days when we used to boot off CD drives and that, if there's a non-bootable disk in the CD drive, for example, and it's still set to boot from the CD drive as a primary source, that will stop the system from booting up. Okay, so just check the boot drive sequence. Okay, in the BIOS, it will tell you what the sequence of drives for the boot sequence is. That's something that you could check. So, problem theories: ensure that the device is powered on, switches, protectors. So, as you could see when I was describing the potential causes in the last slide, I was kind of leading on to the theory on the cause. Why do we check to make sure the cables are connected? Well, if the cables aren't secure, it's not going to be working. A loose video cable means that you'll get a blank screen. A loose power cable means something won't turn on. Okay. So how do you come up with an action? Well, if you're on the help desk, it's going to have a database attached to it with where you type in the symptoms and it'll come up with potential issues and solutions. Number one is turn it on, turn it off, turn it on. Talk to other technicians, especially when you're learning. Frequently asked questions. Websites in various forums will help you as well. The news groups, computer manuals, device manuals, all of that sort of stuff. And basically, way down the bottom of this slide is generally the go-to that everybody uses, which is the internet search. They don't bother looking at manuals and that. Ask Uncle Google and he shall inform. So verify that the system has restored itself. So reboot it, make sure it's working correctly. Verify that it can access everything it needs to access that may have been affected by the problem. And if the client is happy, move on and document it. So you need to document what the issue was, what caused the issue, what you did to resolve the issue. Okay, so why do we need to document this? So that next time when it happens, you have a record of what you did. Because trust me, when you come across something, the back of the head will be going, I've come across this before, what did I do? It may be 18 months since the last time you came across the issue, or more. And as you get older, your memory starts to play tricks. Just there. So rather than having to start from scratch time and time again, by documenting the problem, you help speed up future issues. So common problems, well, obviously the common one is not having power. So the next one is incorrect cable connections, really. The number of times, especially with laptops and that now that are moving, things rattle loose. Okay, screws, cable connections, plugging things in and out repeatedly, loosen the sockets. So all of this combines to cause issues over a long period of time. And users, you know, they will have formed an opinion before you engage them. So you need to get past their opinion of what the solution is and do your own diagnostics. Okay, so motherboards are, again, drivers up, things like that for motherboards, software interfaces. Not so much in modern computers because it's all plug and play. So having incorrect drivers and that, especially in Windows 10, as very rare that is now a current issue, but on the older systems it can occur. Faulty power supplies, dust build-up in the power supply can actually cause the power supply to become faulty. So when you're blowing out the dust and everything, make sure you give the power supply a really good clean as well, because it has higher voltage issues within the power supply, so it can arc out more easily. Memory problems are generally caused by not seating modules correctly in today's environment, so just give them a check. It's pretty hard to do a faulty CPU installation because they're keyed, but it can happen. Again, check your cooling, your fins on your heat sinks and all that. Make sure your fans are still turning. Quite often, if there's a fault with the CPU overheating and things like that, maybe the fans had better days and needs to be replaced. I've definitely replaced faulty fans over the years. The displays, people trying to up the resolution above what their monitors are capable of because they've got a new fancy graphics card. Or you might have a smart ass in the office that's going around rotating screens 180 degrees and that sort of stuff in the software. I may or may not have been guilty of that in my youth. Yes, there's a combination of keys that will rotate the screens on the display, causing chaos in the office. Just those little things we used to do to annoy people that annoyed IT support. So the next series of slides and screens, when you read this chapter, will go through combination of issues. So on the left hand side you'll select, okay, computer will not eject the optical disc, check the power supply is connected to the CPU. If it still won't let go, if it's got power and connections, there is a pinhole on the front of CD drives. Get a thin, solid, basically a paper clip, something like that. You press it in through the hole and that manually releases the drive. If you've got a stuck disk in an optical drive, you can always manually override the drawer and get it to pop manually. Some of the things, especially if you're dealing with machines that go to home, young children can be very creative in what they place inside computers. If there's a hole, they can find something to put in it. Okay. I've found some interesting things over the years inside of electronics. All right, so again, going through, okay, computer here is the problem. It won't keep the time. Every time it reboots, it loses its time, date, that sort of thing. That points to the CMOS battery straight away. Okay, so generally replace the battery. In this day and age, loose CMOS batteries are very rare. In the ancient days of my youth, we didn't have the circular batteries on the motherboard. We had 2 pins that we plugged in the power supply, and we used AAA batteries in a holder connected to the motherboard to, yes, I'm showing my age. Yeah, moving on. Oh, computer won't turn on. Well, check your powers, check your power boards, make sure the switch hasn't been turned off. I remember one organisation used to record power outages around about the same time every night on servers and that. The cleaners would unplug the power cable out of the socket because they wanted to use the socket to vacuum up in the room. This is the problem if you do not have dedicated power supplies running on 15 amp separate supplies direct to racks and things like that. If your systems have just grown organically in a small office, they could be just running off normal power points, and people may just unplug them. It took a while to get that one resolved. Another one that I have seen is network cards with the same MAC address imprinted on them from the vendor. That caused network issues for about 4 days before we worked out what was the issue there. Computer will not boot and locks up is generally an indication of heat problems. Okay. So check your fans, check your ventilations are not congested. The other thing is make sure you have appropriate heat sinks on the CPUs. It'll be running for a random amount of time and then just freeze. Nothing. So you'd still have things on display, but it'll just lock up. So nothing. It all stops. Okay. It cannot make calculations because it's gotten too much heat and the CPU is in the process of shutting down. So modern CPUs will degrade before they just turn off. So eventually it'll get to the stage where the computer is still on. In other words, the graphics card will still display the last images that it was sent, but the CPU is basically shut down. So it won't update things like moving the mouse around or the keyboard inputs. And you've got to hold the power button down for the 5 seconds for it to power cycle. Okay, so that's locking up. So when it becomes unresponsive. Alright, so again, I'll let you read through these. I'm not just going to read them to you. So basically, this chapter will be, here's a potential issue on the, okay, because again, these PowerPoints are taken straight out of the chapter. So you'll have the graphics on the side, you click on the thing, and you come up with solutions over on the side. So power, I cannot stress the number of times, connections. Yes, I copped this recently. I was teaching at Homesplan at night. The monitor cable for the overhead projector, they had a adapter that went from the HDMI to DVI, I think it was, and the plug didn't screw together, so it was just pressed together. So if somebody moved the cable, moved the desktop, it would just come apart and you wouldn't have an overhead projector. And it was tucked in right in underneath the desk where you couldn't easily get to it. So it took a while to sort that one out. So this is examples of where you need to check your cabling, because they're very easy to get, because cable vendors and adapters and that, they're making them as cheap as possible now, so they're not actually putting in like the old ones where you used to have screw locks to lock the joins together. Okay, so they can save a couple of cents per unit by not putting in those locking mechanisms on those adapters anymore. So the issue is that they come apart very easily. Okay, so troubleshooting guides, journals are very important for you to keep, especially with you starting off, because by keeping notes on what the symptoms were and what the solutions to those issues are, what you did to make the problem go away, you can build up your own database of problems that you've come across. And if you keep your journal in a logical manner, you will develop a very nice reference book where you can quickly search up symptoms, find potential solutions very quickly, and make yourself very efficient with fault finding. Because let me assure you, when something goes bang, senior management don't give a rat's ass about what the cause was and that sort of thing. They just want it fixed, and fixed fast. Because when something's down, it's costing them money, and if it's down too long, it's cost more than your wages, so therefore you're the expendable one, not the hardware. So just be aware of that one. So internet reference tools, Google. Now that is the most common answer that is thrown out there, but just be aware that the potential solutions that you get off the internet, a lot of them could be red herrings. Okay, just because it's out there on the internet doesn't actually make it so. Develop your own sense of what could be possible and what can't be possible. You will develop that sense over time as So always take things on the internet with a grain of salt. I'm sure you've already seen that over the years. So advanced problem solving, guess what? There is no advanced problem solving, it's just problem solving. Okay, I'll give you the heads up. Basically, all what you end up doing is the issues that you need to face get more difficult as your skills increase. So what they're saying is advanced problems is as you get better at doing diagnosis and repairing things, your employers will throw you at harder and harder issues because your experience gets better. More expansive, you become better at fixing things, and they'll throw you at more and more difficult problems that other techs have failed to resolve. Okay, so as your troubleshooting skills increase, so do the difficulties that get thrown your way. There are levels of support for a reason, and they've got to do with the experience of the individuals that are in each level. So a level 1 support tech compared to a level 3 is experience. Okay, so the more experience somebody has, the more the go-to person they become. So they become the person that gets thrown the harder issues. That's basically what the advanced problems and solutions refer to. So yes, using a multimeter and power supplies. No, we won't when we get back to the classroom. Yeah, the occupational health and safety issues revolving around students plugging in testing prongs into power supplies are too high. So generally speaking, when we get back in the classroom and we've got the hardware and that, I will be getting you to build your machines. I will inspect them. I will then break them in a repairable fashion, and then you get to come in and troubleshoot the issue and try to resolve what I did. It's where I get to play. Okay, so preventative maintenance is performing regular activities to keep the efficiency of the device going. Yes, Stuart, it is a perk of the job of being the teacher in this particular subject. Is, mind you, I've had some very creative students over the years. A few years ago, I had a student that I could slow him down. The best one I had was getting him to do password recovery on a desktop without him having any software tools to do it. He did it. It took him an hour and a half, but he did it. So he managed to hack into a secure PC and change the passwords on me. So there's some, yeah, without external, I've got software tools that I can just load up and reboot and scrub a password. Not an issue. But he did it without any of those tools. I thought I had him stumped there for that day, but no, that little rat. But he was very good. keeping him challenged was the issue in that classroom. Okay, so today we just had a quick look at preventative maintenance, troubleshooting. As I said, troubleshooting, just understand you've got to approach it logically at the moment and follow a series of steps to the troubleshooting process, and you will develop an instinct for how to resolve these issues as you get more experience. Troubleshooting is not something we can really teach you. Troubleshooting is something we can guide you along the path of the process, but the actual skills you will learn and develop as you do. Okay? Troubleshooting is just about experience. Okay? You need the experience to develop the history and the knowledge of what the problems are and what possible solutions there are. Nothing else there that can do it.